White holes are curious mathematical opposites of black holes.
Have scientists finally uncovered the mystery of white holes? We've long been fascinated by the gravitational pull and mysterious nature of black holes, celestial whirlpools from which nothing can escape. But what if we told you there might be a cosmic twin to the black hole, a white hole? Unlike black holes, which pull everything in and hold it at a singularity of infinite density, white holes are the opposite. They seemingly push everything away and refuse any matter or energy to enter. Scientists theorize that white holes could be the antithesis of black holes, representing the other side of the cosmic coin. Black holes are born from the collapse of massive stars, compressing their mass into an incredibly dense point. Their immense gravity forms an event horizon, the point of no return from which nothing, not even light, can escape. White holes, on the other hand, are suggested to be regions where matter and energy are explosively expelled, rather than being sucked in. Instead of consuming matter, a white hole continuously expels it into the universe. It could potentially serve as a gateway to another universe, if not within our own. Although we have observed and captured images of black holes, their white hole counterparts have remained elusive. However, scientists may have finally discovered the evidence they have been seeking: mysterious gamma rays appearing where they shouldn't be. Gamma ray bursts, incredibly intense bursts of gamma ray light, lasting from a fraction of a second to a few minutes, are the most energetic events in the universe. They release as much energy in their short duration as our sun does throughout its entire lifetime, and can be hundreds of times brighter than a supernova. These bursts occur when a black hole is formed. Among the gamma ray bursts, scientists have encountered an exceptionally unusual one. It seemingly manifested abruptly, only to rapidly collapse onto itself. Despite lasting approximately 100 seconds, it exhibited characteristics of a much shorter burst. This particular gamma ray burst, named GRB 060614, lacked the typical afterglow associated with black holes. Consequently, scientists speculate that this peculiar burst may serve as evidence of a white hole. Now let's delve into one of the most enigmatic entities in the universe. Embarking on a journey to a white hole comes with a hefty price tag. If you were to traverse the universe in search of this theoretical phenomenon, what you would encounter would resemble a black hole. A desolate void surrounded by a ring of dust and gas, shielded by an event horizon. However, rather than being drawn towards the singularity at the center, your experience would turn tumultuous. Once inside the vicinity of the white hole, your spacecraft would be subjected to a relentless onslaught of intense gamma rays, threatening to disintegrate both the vessel and its contents. The destructive power of these rays would be so immense that even the most fantastical, yet to be invented super-advanced gamma protective technology would be stretched to its limits in attempts to safeguard your survival. Despite any miraculous means of enduring this onslaught, breaching the event horizon of the white hole would prove to be an insurmountable challenge. The radiation emanating from the white hole, akin to an unyielding torrent, would perpetually hinder your forward progression, comparable to the arduous task of combating colossal air resistance experienced on Earth. Your spacecraft, akin to an intrepid explorer ascending an uphill path, would be incessantly buffeted by an unrelenting and tempestuous wind, propelling you away from the desired destination. As you steadfastly endeavor to overcome these monumental obstacles and press onward, the demands for energy would exponentially escalate, particularly as the white hole draws nearer. A critical juncture would eventually be reached, where the staggering quantities of energy required to advance would surpass the entirety of energy encompassed within the entire universe itself. Now imagine the opposite of a black hole, a white hole. While black holes trap everything within their event horizon, white holes are believed to expel matter, energy, and even information. Essentially, they are thought to be the antithesis of black holes, spewing out the very things that black holes voraciously consume. Venturing into a white hole would present an extraordinary opportunity to explore its singularity. Just as black holes are theorized to contain a singularity at their core, a point of infinite density and gravitational force, white holes may possess their own singularity, albeit one that repels matter instead of engulfing it. To compound the intricacy, achieving velocities surpassing the speed of light, the ultimate cosmic barrier, would become an essential prerequisite, an infeasible task, governed by the constraints of our current understanding of the laws of physics. Nevertheless, there might exist a potential route to reach your destination, by first entering a black hole. Scientists theorize the presence of a wormhole connecting the white hole to its black hole counterpart, which could serve as your only passage. However, it is crucial to note that this passage through the wormhole would be exceedingly unstable, with the potential to collapse unexpectedly at any given moment. It is highly advisable not to be inside when such an event occurs. Consider yourself warned. Assuming you possess the courage to leap into a black hole, your first task would involve traversing its event horizon. Once inside, you would witness another intense burst of luminous energy. Subsequently, the black hole's surroundings would appear to expand, enveloping you within a ring of light. The disorientation would likely be profound, giving the illusion of a free fall back through the black hole, although this would not be the case. This perceptual distortion is known as relativistic beaming. Naturally, this extreme scenario would not be devoid of additional mind-bending effect. Overcoming the impossible task of surpassing the cosmic speed limit, you would confront the most formidable gravitational forces tugging at you from behind. Consequently, your entire body would undergo severe stretching, resembling the phenomenon of reverse spaghettification. Furthermore, the disorienting consequences of relativistic beaming would create the illusion of the black hole shrinking ahead, as if you were gradually moving farther away. Eventually, you would successfully overcome the gravitational pull and forcefully propel yourself out of the event horizon. At this point, you would be expelled from the black hole's other side, entering an entirely distinct region of our universe, or, conceivably, even venturing beyond it. Remember, after traversing a black hole and then a white hole, the realm of possibilities becomes boundless. Approximately 13.8 billion years ago, our universe originated from a singularity, encompassing all the matter and radiation that exists today. It is conceivable that you have just traversed the black hole responsible for birthing our universe. This implies that you are embarking on another extraordinary voyage of exploration and revelation. However, it is important to recognize that this undertaking might not be as straightforward as anticipated. There is a distinct possibility that you have entered a universe governed by completely different laws of physics, diverging from our familiar ones. Perhaps it would be more prudent to consider exploring another intriguing discovery made by scientists, such as an astonishing planet bearing an uncanny resemblance to Earth. And there you have it, fellow space explorers. We've taken an exhilarating journey into the depths of the unknown, exploring the unfathomable realm of white holes and the immense challenges they present. While the prospect of falling into a white hole may seem daunting, we've armed you with essential knowledge and strategies to navigate this mind-bending scenario. Always remember, exploration is about pushing the limits of what we know and embarking on extraordinary adventures. While the survival strategies we've discussed today are purely speculative, they ignite our imagination and inspire us to ponder the mysteries of the cosmos. Until next time, keep looking up at the stars, and remember that even in the face of the extraordinary, humanity's thirst for knowledge and discovery will always prevail. Safe travels, fellow cosmic adventurers. Keep dreaming big and exploring the infinite possibilities that await us among the stars. If you've enjoyed this cosmic exploration and want to delve deeper into the wonders of the universe, don't forget to like, subscribe, and hit that notification bell to join our community of fellow space enthusiasts. Share your thoughts, questions, and ideas in the comments below, and let's continue to unravel the secrets of the cosmos together.